All right, ladies and gentlemen, we are looking at 2.1. Here's a little setup for you. Sibling or imposter, you have spent some time with Mugwump and the company, explained in a paragraph or two, probably just one paragraph, don't worry, how to tell the difference between Mug's siblings and imposters. Be sure to give concrete examples and to justify and explain your answer. So looking at these guys, write a paragraph about, well, which one looks like Mug? Which one just looks like a larger version of Mug, and which one does not look like a larger version of Mug, like they're stretched out or they're pulled or something like that? That's what I want you to do. Explain in a paragraph how to tell that. You can pause the video, write that down on that paper that you have, maybe down here, and come with that tomorrow morning. We'll talk about it. All right. Here are the answers to your questions that I sent you home with from yesterday. Mug should look like this. Lug is all stretched out. So when it was multiplied 3x and y stayed the same, well, he's not taller at all than Mug, but he is stretched out from side. He's 3 times wider than Mug is because we multiplied 3 times x. Bug, we did 3x and 3y. Well, he's 3 times bigger. He's stretched out sideways and bigger. He is part of the Wump family for sure. He is a sibling, not an imposter. But Glug over here, he is a very tall imposter because our rule for him, if you go back to it, was x comma 3y. So he is 3 times taller than Mug because we multiplied 3 times the y-axis. Today we're looking at hats. Zach experiments with multiplying Mug's coordinates by different whole numbers to make other characters. Marta talks about how multiplying coordinates by decimal or adding coordinates to or subtracting numbers from each coordinate will affect Mug's shape. Well, we have this. Look at this. This is interesting for the hats. Mug's hats, okay, I want you to go back to that, and I want you to get down the coordinates. Pause the video if you need to, but get down the coordinates for Mug's hat. They already have the first two, 1, 1, and 9, 1. 1, 1, 9, 1. I'll tell you the next one, it's 6, 2, and then 6, 3. 4, 3, 4, 2, and then back to 1, 1. If you didn't get that, rewind the video. All right. Getting that down. All right, now that we have these coordinates down, here's what we're going to do differently. We're not multiplying today except for hat 3, 4, and 5. Look at the rules. This time we're adding. So for 1, 1, we are adding x plus 2, y plus 3. So our new coordinate is going to be 3, 4. Make sure to place that up here for A. Our next coordinate, 9, goes in for x, so 9 plus 2 and 1 plus 3. Add that in. 11, 4. You finish up with the rest of the graph. Always go back to Mug's hat, these original coordinates for x, y. X minus 1 and y plus 4 in this. X plus 2 and 3 times y. Don't mess that one up. It's 3 times y. 0.5 times x and 0.5 times y. Yes, you will have decimals. And 2 times x and 3 times y. Pause the video if you need to, fill those in. And then we'll look at the answers right here. Here are the answers. Fill those in if you didn't take the time to do it. Maybe you're a little lazy. That's all right. But I wanted you to fill these in. Get the correct coordinates. All right. What I want you to do now is I want you to actually plot these coordinates. I want you to plot Mug's hat, Hat 1, 2, 3, 4, and 5. Again, Mug's hat 1, 2, 3, 4, and 5. Okay, now that you've plotted these, just compare them with the answers. Here's Mug's hat. Well, hat 1 doesn't look any different, except it's just in a different position. Hat 2 doesn't look any different, except it's just in a different position. So what can we say about adding or subtracting to the coordinates? The only thing that affects the actual hat is its position. When we add and subtract to the x and y, the only thing that's affected is its position. Look at this one. Yeah, we added, but this one gets 3 times taller because of the 3y. This one, hat number 4, is half the size because we did 0.5 times x and 0.5 times y. So it's half as tall, half as wide. But then this one, hat number 5, is 2 times as wide and 3 times as tall. Check your answers, check yours to make sure that they're correct. All right, compare the angles and side lengths of the hats. Well, compared to Mug's hat, all the angles and the sides are the same for hat 1, hat 2, and Mug's hat. For hat 3, this side length is the same. This side length is the same. But all the ones going up, the side lengths are different because we multiplied 3 times y. All the side lengths here are going to be half as large. But you know what? For hat number 4, if you compare it to Mug's hat, we would actually measure this out. The angles are going to be the same. It's just the side lengths that change. Now, for rule 2x, 3y, I'd like to say that the angles are going to be the same, but they're not because they weren't multiplied by the same number. These two were multiplied by the same number, 0.5. This rule, 2 and 3, nope, not multiplied by the same number. So the side lengths will be different and the angle measures will be different. These are not similar. Which hats are similar to Mug's hat, and explain why? Well, I know that hat 1 is the same, and yes, that's similar technically. Hat 2 is the same, and yes, that's similar. Hat 3 is not similar. Hat 4, you know what? It's multiplied by the same number. That's similar. It's the same shape, just a different size. And hat 5, no. I wish it were similar, but it's not. This one was multiplied by 2. This one was multiplied by 3. Not similar. Write rules that will make hats similar to Mugs in each of the following ways. The side lengths are 1/3 as long as Mugs. Well, you know what? This rule, 0.5x, 0.5y, made it half as small. So if we wanted to go 1/3 as small, I want you to write the rule right over here. Same with side lengths, 1.5 times longer. I'll tell you that if this was half as long, they were multiplied both by the same number. If we want to go 1.5 times longer, hopefully we're going to multiply it by the same number. And the hat is the same size as Mugs, but is moved right 1 unit and up 5 units. Remember, it's the same, but it moves up 1. Again, it moves, moves to the right 1 and up 5. This one moved to the right 2 and up 3. Look at this rule. Moved to the right 2 and up 3. You have to move it to the right 1 and up 5. How are you going to do that? Write that right here. And write a rule that makes a hat that is not similar to Mugs. You have a perfect example right here. 2x, 3y. X plus 2, 3y. Not multiplied by the same number. So just come up with a rule That is not multiplied by the same number. We'll go over D and E in class tomorrow. If you have any additional questions, please make sure to ask. Otherwise, that is the end. Have a great night.